So today we're going to be studying combining like terms. This should just be review. So if I had something like 4x plus 3x, what do I get? I get a bunch of boxes in my way. 7x. Why is it 7x? Okay, why don't we multiply, or why is it not? So obviously 4 plus 3 is 7. That's true. Why isn't it 7x squared? Okay, good. The x's aren't squared. What is 4x? It's 4 times an unknown number. Okay. Is there a way to build 4x? Yeah, math teachers don't usually ask you that sort of question. But 4x is just an easier way to write down 4 copies of x. So this is just x plus x plus x plus x. Right? What about the 3x? It's just x plus x plus x. So whenever I add variables, all I'm doing is counting how many there are. So I count this 1, 2, 3, 4, 5, 6, 7, 7x. It's not x squared because, like Dewey said, we don't have any x squareds. All we have are x's. Okay? So what if I had 2x to the third plus 6x? How do you combine those? I can't. Why not? So what is 2x to the third really telling me? What is 2x to the third in this sort of fashion? It's x to the third plus x to the third. I have 2 copies of x to the third, right? Okay. Right, so this here can be turned into that. What is 6x really? It's just 6 copies of the variable x. So 1, 2, 3, 4, 5, 6. Now when you look at it that way, how many x to the thirds do I have? 2. How many x's do I have? 6. Can I combine them? No. It's like saying we have 2 apples and 6 oranges. How many apple oranges do I have? None. They don't exist. Right? When you're counting apples and you're counting oranges, they are not like terms. You cannot combine them because they're 2 different things. Okay, so an x to the third and an x cannot be added because they're different fruit. Does that make sense? Okay, what if we turn to multiplication? What if we had 4x squared times 2x to the fifth? How do we multiply those? We have to do something with the powers. Well, let's break it down. What is this really? So 4 copies of x squared. So we have x squared plus x squared plus x squared plus x squared. Okay. What about the next one? Or wait, sorry, they're not plus. No, that's right. That's right. And then what's the next one? So that's multiplied by 2 copies of x to the fifth added together. Okay. Well, what is an x squared in terms of multiplication, not addition? How do you get x squared using x's? X times x, right? If you add the same number over and over, you can simplify it into a multiplication problem. If you multiply a number over and over, you can simplify it using, so let's go back up. So if I have repeated addition, maybe I'll write this down. So repeated addition turns into multiplication, right? X plus X plus X plus X can be simplified to 4X. Agreed? Okay. Well, what if I have X times X times X times X? Exponents, right. So if I have repeated multiplication, that turns into an exponent. So this would be X to the 4th. Okay, so let me show you that down here. This turns into 4X squared, right? And this turns into 2X to the 5th. So this is really 4 times X times X. That is 4X squared. Does everybody agree? Repeated multiplication turns into exponents. Okay, and then this would be 2 times 5x's. Are they added or are they multiplied? Multiplied together. So x times x times x times x. So what does that equal? Well, what is 4 times 2? 8. Okay. Now what? Yes, why 6? Or sorry, 7. Why 7? You add the exponents. That's the rule we're headed towards. But when you look here, why is it x to the 7th? Oh, I'm missing one, right? That's why you mixed it up. I messed up too. Okay. Why is it x to the 7th? I'm counting the multiplications. Right? Up here, why was this 7x? Because I counted the x's. There are 7 x's in that list, and they're added, which means it turns into 7x. So down here, I have 4 times 2, which is 8, and then I just count my x's. 1, 2, 3, 4, 5, 6, 7, and because they're multiplied together, that 7 is an exponent. So 8x to the 7th. Okay, now you've done this before, but does that kind of make a little bit more sense? So up here, we have 4 apples and 3 apples. We add them together, we end up with 7 apples. Down here, we have 2 oranges and 6 apples, and you can't add apples and oranges together. There's no such thing as a orange or apple, right? They don't exist. So this cannot be simplified because we're looking at 2 different fruit. And then down here, we're multiplying, and 4 times 2 is 8, and then all we do is count the number of x's, but because it's multiplication, the number of x's becomes the exponent as opposed to the coefficient. So I'm going to be using this word a lot. These numbers in front of the variables are called coefficients. So addition will change the coefficients, and the exponent will remain unchanged. Multiplication will change the exponent and the coefficient also. Okay. Does that kind of make a little bit more sense? Okay, and this is something that we absolutely have to understand if we're going to move forward. So, okay. I thought I messed something up, but I didn't. All right, so look at number 1 on your assignment. Negative 6k plus 7k. Are those like terms? Yes, why? They're both k to the 1st, right? So if you look there, there's a 1 there and there's a 1 there. This variable matches that variable. The 6 and the 7 don't match, and that's okay. But the k's match. The k and the variable match. So what is negative 6k plus 7k? Would be negative 1k or just negative k. All right. Oh my goodness. I'm sorry. I don't know how I graduated from college. How about just k? I was just testing you. You passed. Look at number 13. So number 13 has 12r plus 5 plus 3r minus 5. Can I add all those together? No, why not? They're not like terms. They're two, well, there are different fruit there. How many different types of fruit do you see? 2. What are they? The r's. And what do we call a number that doesn't have a variable? It's called a constant because it doesn't vary. It doesn't have a variable, so it's constant. So in this problem, we have r's that match, and then we have constants that match. So I can add my variables, and I get 15r, and then I can add my constants and get 0. If you have 5 apples and you take 5 away, you have no apples left. What if I had 12r minus 12r? Would it be 0r? Would it just be r? 0r? No, nothing? Well, it's certainly not r, because what would r mean? 1r. And if you have 12 and you take 12 away, you get 0. But what is 0r? It's nothing, right? 0 times r is 0, no matter what. So you wouldn't need to write it. But I guess if you wrote 0r, you wouldn't be wrong. But anything that turns into a 0, we just leave it out. Okay? All right, turn the page. Look at number 21. So negative 4 plus 7 times 1 minus 3m. What do we need to do here? We need to multiply the 7 in. Do you remember what that's called? Starts with a D. Distribute. So we need to distribute the 7 in. So I get negative 4. And what is 7 times 1? Plus 7. And then what is 7 times negative 3m? Negative 21m. Okay. Can I combine like terms? Which part? What do we call those? The constants. I can put the constants together. So these turn into 3 minus 21m, and usually we would put the variables in order from highest exponents to lowest. They didn't on the answers for this worksheet, but if you wrote 21m plus 3, that would be also correct. It doesn't really matter, but if you see it either way, it's going to work. Okay, number 29 will be the last one we do together. Negative 3 times 10b plus 10 plus 5 times b plus 2. What should I do here? Distribute the 3 in and distribute the 5 in. So I'll multiply those in, and I'll multiply that in. What is negative 3 times 10b? Negative 30b, good. Minus 30, and let's stop here for a second. What is a positive times a positive? Oops. Positive. What is a positive times a negative? Negative. What is a negative times a positive? Negative. And what is a negative times a negative? Positive. Okay. Does anybody not understand why that's the case? Everybody okay on that? We're all right? Okay. Good. And then what's the next distribution going to give me? Plus 5b plus 10. Do I have like terms? Yes. How many sets of like terms do I have? 2. What are they? The b and the constant. So I put my b's together. Negative 30b and 5b turns into negative 25b. Why did that end up being negative and not positive? Because the negative is stronger, right? Whenever you have a negative and a positive added together, they kind of fight it out, and whoever's tougher wins. So the negative 30 was tougher. How much tougher? 25. Does that make sense? Okay. And then what about negative 30 plus 10? Negative 20. Okay. We good there? Okay. Can you do this assignment and it will be due tomorrow? All right. If you look on the website tonight, the answers will be posted. So this assignment will be listed on the website, and the first 2 pages look identical to yours. The second 2 pages have the problem and the answer on there. So if you want to know if you're doing them correctly, log on to the website tonight and go to our class and click on the PDF, and you'll download it and look at pages 3 and 4, and you'll see the answers. Okay? All right. Good luck.